You're not getting dumber because you're aging. You're not getting dumber because the world is more complex. You're getting dumber because of 6 psychological habits you perform every single day, voluntarily, without anyone forcing you, and most of them feel productive while they're happening. That's the cruel part. A study published in the journal Nature Human Behaviour tracked cognitive performance across 14,000 adults over a decade and found that the sharpest declines had almost nothing to do with genetics or education. They had everything to do with behavior. Daily, repeated, self-inflicted behavior. And the worst part? When researchers told participants what was causing the decline, most of them didn't stop. They couldn't. Because these habits don't feel like habits. They feel like life. So here's what nobody is telling you. There are 6 things you are almost certainly doing right now, today, this week, that are measurably, provably, scientifically making you less intelligent. Not in some vague, hand-wavy, be your best self kind of way. In a your brain is literally shrinking kind of way. And by the time you finish this, you'll understand exactly why stopping feels almost impossible, and what the science actually says about reversing the damage. Let's start with the one that sounds the most boring but is secretly the most devastating: sleep. Or more accurately, the lack of it. Here's the thing about sleep deprivation. Everyone knows it's bad. That's not news. What is news is how catastrophically bad it actually is, and how little sleep loss it takes to reach that point. Most people think sleep deprivation means pulling an all-nighter, staying up for 36 hours straight, something dramatic. But the research tells a completely different story. A landmark study from the University of Pennsylvania took 48 healthy adults and restricted some of them to just 6 hours of sleep per night. Not 4, not 2, 6. Which, by the way, is what roughly 35% of American adults report getting on a regular basis. After just 2 weeks, the 6-hour sleepers performed on cognitive tests at the same level as someone who hadn't slept for 48 hours straight. Their reaction times were destroyed. Their working memory was gutted. Their ability to sustain attention collapsed. But here's the part that should genuinely terrify you. They didn't know it was happening. When researchers asked the 6-hour sleepers to rate their own cognitive performance, they consistently rated themselves as slightly tired but basically fine. They had no awareness of how impaired they actually were. The researchers called this subjective adaptation to chronic sleep loss. In plain English, your brain gets so used to being broken that it forgets what working properly even feels like. It's like slowly going colorblind and not noticing because you still see something. You just don't realize the red is gone. And the mechanism behind this is brutal. During deep sleep, your brain activates what's called the glymphatic system. Think of it as a biological pressure washer for your neurons. Cerebrospinal fluid floods through the spaces between brain cells and physically flushes out metabolic waste, including beta-amyloid and tau proteins. Those names might sound familiar. They should. They're the same proteins that build up in the brains of Alzheimer's patients. When you sleep 6 hours instead of 8, you're cutting your brain's cleaning cycle short by roughly 25%. Night after night after night, the waste accumulates. Synaptic connections weaken. The prefrontal cortex, which is the part of your brain responsible for planning, decision-making, and impulse control, is the first area to degrade, which means the exact part of your brain you'd need to recognize and fix the problem is the first part the problem destroys. Pretty clever design flaw, right? And that's the uncomfortable parallel. Just like your brain needs deep sleep to clear out physical waste, it also needs conscious work to clear out psychological residue, old patterns, inherited narratives, unexamined shadows. If you don't actively process them, they accumulate quietly and start shaping your decisions from the background. If you're ready to go deeper and deliberately integrate both your shadows and your light instead of letting them run on autopilot, check out the Sim Method ebook. It's a concise guide designed to help you unlock your inner power in just 5 minutes a day. The link is in the first pinned comment below. Matthew Walker, the neuroscientist at UC Berkeley, who has probably done more sleep research than anyone alive, puts it bluntly. He says there is no major organ in the body and no process within the brain that isn't optimally enhanced by sleep and demonstrably impaired when you don't get enough. No major psychiatric condition exists where sleep is normal. Every single one shows disrupted sleep. That's not a coincidence. That's a smoking gun. But here's where it gets worse. Because even if you fix your sleep tonight, the damage from chronic deprivation doesn't just vanish. Research from Michigan State University found that chronic sleep loss causes measurable reductions in gray matter volume in the prefrontal cortex. The brain physically shrinks. And while some recovery is possible, the timeline isn't days or weeks. It's months, sometimes longer. So every night you tell yourself you'll catch up on sleep this weekend, you're operating under a delusion that the science simply does not support. Sleep debt doesn't work like financial debt. You can't just make a big payment and zero out the balance. The interest has already compounded. The damage is already structural. And the really insidious part? Because the prefrontal cortex is the first thing to go. The very act of deciding, I'll just sleep less tonight, is itself a symptom of the impairment. You're using a damaged decision-maker to make decisions about the thing damaging it. It's like asking an arsonist to run the fire department. Military survival training teaches recruits that sleep deprivation is one of the most effective tools for breaking someone psychologically. After 72 hours without sleep, hallucinations begin. After 96, psychosis. But what the military also knows, and what most civilians don't, is that the subtle cognitive erosion at 6 or 7 hours per night is in many ways more dangerous than acute total deprivation. Because with total deprivation, you know something is wrong. With chronic partial deprivation, you have no idea. You walk around thinking you're operating at 90% when you're actually at 60, and you'll defend your sleep habits aggressively, because admitting the problem would require the cognitive resources you've already lost. One researcher I talked to described it like this. Imagine you have a car with a dashboard that shows your engine temperature, oil level, tire pressure, everything you need to know about whether the car is functioning. Now imagine someone slowly dims those dashboard lights, 1% per night, for years. Eventually the dashboard is completely dark. The engine is overheating, the oil is gone, the tires are flat. But you keep driving because the dashboard says everything is fine. That's what chronic sleep deprivation does to your self-awareness. It doesn't just break the engine. It breaks the warning system that would tell you the engine is broken. And that brings us to the next thing making you dumber, which is probably happening at the same time you're not sleeping enough, because they feed each other in a vicious loop that almost nobody talks about. What you're eating. Now, before you roll your eyes, this isn't a nutrition lecture. This isn't about weight. This is about what happens inside your skull when you consume the standard American diet, which is loaded with ultra-processed foods, refined sugars, and industrial seed oils. And the answer is nothing good. Here's the thing about your brain and sugar. Your brain is roughly 2% of your body weight but consumes about 20% of your daily calories. It's the most energy-hungry organ you own, and it runs primarily on glucose. So you'd think more sugar would mean more brain power. Makes sense, right? But it's exactly backwards. A study from UCLA found that rats fed a high-fructose diet for just 6 weeks showed significant impairment in synaptic activity. Their neurons fired more slowly. Their ability to form new memories degraded. Their maze-solving performance, which had been trained to a high level before the diet started, collapsed. 6 weeks. That's all it took. And this translates directly to humans. Research published in the journal Neurology followed over 5,000 people for 10 years and found that individuals with higher blood sugar levels, even those who weren't diabetic, showed faster rates of cognitive decline and greater hippocampal shrinkage. The hippocampus is your brain's memory center. It's where short-term experiences get converted into long-term knowledge. When it shrinks, you don't just forget where you put your keys. You lose the ability to form the kind of deep, connected understanding that makes someone genuinely intelligent. But the sugar problem is only half the story. Ultra-processed foods, the kind that make up roughly 60% of the average American's caloric intake, contain compounds that directly damage the blood-brain barrier. This is a critical layer of cells that controls what gets into your brain and what doesn't. Think of it as a bouncer for your neurons. When the blood-brain barrier is compromised, inflammatory molecules that would normally be kept out start flooding in. This triggers neuroinflammation, which is essentially your brain's immune system going haywire and attacking its own tissue. It's like having a security guard who starts letting in everyone with a weapon and then wonders why there's a fight. A fascinating study from Australia's Macquarie University demonstrated this in real time. They took healthy young adults with normal diets and had them eat a standard fast food breakfast, a sugary milkshake paired with a processed sandwich, for just 4 consecutive days. After only 4 days, participants showed measurable impairment on the hippocampus-dependent learning and memory test. 4 days. Not 4 months. Not 4 years. 4 days of eating what millions of people eat every single morning. The weird part is that this creates a feedback loop that makes it almost impossible to stop. When your prefrontal cortex is impaired by poor diet, your impulse control drops. When impulse control drops, you reach for more junk food. When you eat more junk food, your prefrontal cortex gets further impaired. The food isn't just making you dumber, it's making you dumber in the specific way that makes you want more of it. That's not an accident of biology. That's what happens when a reward system designed for scarce environments encounters unlimited processed calories. And one guy, a neuroscientist named Chris Van Tullochen, actually tested this on himself for a documentary. He ate an 80% ultra-processed diet for 4 weeks and then got brain scans. The results showed that areas of his brain associated with reward processing had formed new neural connections to regions associated with automatic, repetitive behavior. His brain had literally rewired itself to crave the food that was damaging it. He described it as feeling like his brain had been hijacked. And when he tried to stop, the cravings persisted for weeks after he returned to his normal diet. The junk food had fundamentally altered the circuitry of his reward system. Same mechanism as nicotine. Same mechanism as gambling. Except this one happens 3 times a day and society calls it eating. But even if you fix your sleep and clean up your diet, there's a third habit that might be doing more damage than both of them combined. And it's sitting in your pocket right now. The way you use social media. Now, this is not going to be some boomer rant about phones being bad. Phones are tools. Tools are neutral. But the specific way most people interact with social media platforms is doing something to their brains that is genuinely unprecedented in human history. And the cognitive consequences are only now starting to be understood. Here's the thing about scrolling. When you open a social media app and start scrolling through short-form content, your brain enters a state that researchers call rapid reward switching. Every 3 to 10 seconds, you encounter a new piece of content. Each piece triggers a small dopamine response, a micro-hit of novelty reward. Your brain evaluates, responds emotionally, and moves on. Evaluate, respond, move on. Evaluate, respond, move on, over and over and over. And each cycle trains your brain to expect reward on a shorter and shorter timeline. A study from the University of Texas measured attention span in college students and found that those who reported heavy social media use showed average sustained attention spans of about 47 seconds during a focused task. Students who used social media moderately averaged about 75 seconds. And students who rarely used social media could sustain focus for around 200 seconds. That's a 4-to-1 ratio. Heavy social media users could sustain attention for roughly a quarter of the time that low users could. And these weren't older adults with declining cognition. These were 18 to 22-year-olds in the prime of their cognitive lives. But the attention span issue is actually the less concerning part. The deeper problem is what happens to your brain's default mode network. This is the neural system that activates when you're not focused on any external task. It's what fires when you're daydreaming, reflecting, making connections between ideas, or processing your own experiences. It's the network responsible for creative insight, self-awareness, and the kind of deep thinking that separates humans from every other species. And it needs unoccupied time to function. Think of it like a garden that only grows when nobody's walking through it. The moment you start scrolling, you've trampled the flowers. When every spare moment, every elevator ride, every waiting room, every bathroom break is filled with scrolling, the default mode network never gets to activate. It atrophies, not metaphorically. Brain imaging studies published in PLOS ONE have shown reduced functional connectivity in the default mode network among heavy social media users. The parts of your brain responsible for your richest, most original thinking are being starved of the one thing they need, which is boredom. Makes sense when you think about it, right? Every great idea in history came from someone staring at a wall, taking a long walk, or sitting in a bathtub. Not from someone scrolling through 30-second videos at 2 in the morning. Isaac Newton figured out gravity while sitting in a garden doing nothing. Archimedes had his eureka moment in a bath. Einstein developed special relativity while daydreaming on a tram. These weren't accidents. These were the products of brains that had time to think. And that time is exactly what most people have completely eliminated from their daily lives. They've replaced every possible moment of stillness with a feed. And then they wonder why they never have original ideas. And here's the part nobody tells you. The damage is dose-dependent, but non-linear. The first hour of daily social media use has a relatively small effect. But after about 2 hours per day, the cognitive impairments accelerate sharply. And the average American spends roughly 2 hours and 27 minutes per day on social media. Which means most people are already past the inflection point. They're on the steep part of the curve and accelerating. But this is where things get really tricky. Because even if you put your phone down and tried to think deeply, there's a good chance you'd struggle. And that's because of the fourth habit, which might be the most insidious of all because it disguises itself as productivity. Multitasking. The human brain cannot multitask. That's not an opinion. That's not a productivity guru's hot take. That is a well-established finding in cognitive neuroscience that has been replicated hundreds of times. What your brain actually does when you think you're multitasking is called task switching. It rapidly shifts attention from one task to another, and each shift comes with a cost. Cognitive scientists call this switch cost, and it's measurable, consistent, and far more expensive than most people realize. Research from Stanford University by Clifford Nass showed that people who regularly multitask with media, meaning they frequently switch between tabs, apps, conversations, and content streams, performed worse on every single cognitive test compared to people who rarely multitask. Not just worse at multitasking, worse at everything. Worse at filtering irrelevant information. Worse at organizing memory. Worse at switching between tasks, which is ironic because that's the thing they practiced most. Nass described the finding as one of the most surprising results his team had ever gotten. He expected heavy multitaskers to be better at least something. They weren't. They were worse across the board, as if the practice of constant switching had degraded the entire cognitive system rather than sharpening any part of it. Here's why. Every time you switch tasks, your prefrontal cortex has to dump the cognitive context of what you were doing, load the context of the new task, orient itself, and begin processing. This takes time and energy. Research from the University of California, Irvine found that after a single interruption, it takes an average of 23 minutes and 15 seconds to fully return to a task. Not to glance back at it, to return to the same depth of cognitive engagement. So if you're checking your email every 15 minutes, you're essentially never reaching deep cognitive engagement at all. You're swimming in the shallows all day and wondering why you never find anything interesting. You're a diver who keeps surfacing for air every 30 seconds, and then complaining that you've never seen the ocean floor. And the long-term consequences are even more alarming. A study from the University of Sussex used brain scans to compare high multitaskers and low multitaskers, and found that chronic multitaskers had less gray matter density in the anterior cingulate cortex. That's the region involved in empathy, emotional regulation, and cognitive control. Their brains had physically changed in response to the constant task switching, and not in a good way. The researchers couldn't determine from that single study alone whether people with less gray matter gravitate toward multitasking, or whether multitasking causes the gray matter loss. But follow-up longitudinal work has leaned heavily toward the latter. The behavior is reshaping the brain. The cruel irony is that the people who multitask the most are usually the ones who believe they're best at it. Research consistently shows a negative correlation between confidence in multitasking ability and actual multitasking performance. The people who think they're crushing it are the ones being crushed the hardest. Pretty much the same pattern as the sleep-deprived subjects who thought they were basically fine. The brain is remarkably good at hiding its own decline from itself. But even if you stopped multitasking tomorrow, there's a fifth habit that might be the hardest one to quit. Because this one doesn't feel like a habit at all. It feels like relief. Avoiding hard thoughts. Every human brain has an almost automatic tendency to flinch away from cognitive discomfort. Psychologists call this experiential avoidance, and it manifests in dozens of ways you probably don't notice. You open a complex article, read 2 paragraphs, feel the mental strain building, and switch to something easier. You sit down to work on a difficult problem, feel the first wave of confusion, and suddenly remember, You need to check something online. You try to think through a personal issue that's been bothering you, feel the emotional weight of it, and reach for your phone instead. This isn't laziness. It's a deeply wired psychological response. Your brain treats cognitive effort the same way it treats physical pain, as a signal to stop. The anterior insula, which processes both physical discomfort and mental effort, activates in nearly identical patterns, whether you're lifting a heavy weight or struggling with a complex math problem. Your brain literally cannot tell the difference between hard thinking and suffering, so it does what it always does with suffering. It tries to escape. And modern technology has made escape frictionless. 100 years ago, if you wanted to avoid a hard thought, your options were limited. You could go for a walk, talk to someone, or maybe read a book. But you'd eventually have to come back to the thought because there was nothing else to do. Today, you have an infinite scroll of easy stimulation in your pocket at all times. The moment a thought gets uncomfortable, relief is one tap away. And your brain learns this instantly. After just a few repetitions, the avoidance becomes automatic. You don't even notice you're doing it. It's like a reflex. The hard thought appears, and before your conscious mind even registers it, your thumb is already moving toward the screen. Here's the thing about this pattern, though. Every time you avoid a hard thought, you're not just missing out on that particular insight. You're training your brain's tolerance for difficulty downward. Like a muscle that atrophies without resistance, your capacity for sustained, effortful thinking weakens every time you bail on it. Research from the University of Waterloo showed that individuals who scored higher on measures of need for cognition, basically how much they enjoy and seek out challenging thinking, performed dramatically better on intelligence tests, problem-solving tasks, and decision-making scenarios. But the key finding was that need for cognition isn't fixed. It's responsive to practice. People who regularly push through cognitive discomfort develop higher tolerance for it over time, and people who habitually avoid it develop lower tolerance. Simple math, really. You get better at what you practice, and if what you practice is quitting, you get very, very good at quitting. This explains something that has puzzled researchers for years. Why do some people seem to get sharper as they age while others decline rapidly? It's not genetics, at least not primarily. It's usage patterns. The brain follows a use it or lose it principle that's almost embarrassingly simple. People who keep challenging themselves cognitively, who read difficult books, learn new skills, wrestle with complex problems, and sit with confusion until it resolves, maintain, and even increase their cognitive capacity. People who spend decades taking the path of least mental resistance see their abilities decline years or even decades earlier than they should. Veteran cognitive researchers know this. They talk about cognitive reserve, which is the brain's accumulated resilience against decline. And cognitive reserve isn't built by what you know. It's built by how hard you've worked to know it. The struggle is the point. The confusion is the signal that your brain is growing. And every time you flinch away from that confusion, you leave potential intelligence on the table. It's like going to the gym, loading the barbell, and then putting it down the moment it feels heavy. You'd never build muscle that way. And you're not building cognitive capacity that way either. But there's one more. And this might be the most dangerous of all, because it doesn't just make you dumber. It makes you wrong. And then it makes you confident about being wrong, which is arguably worse than being dumb in the first place. Confirmation bias. Or more specifically, the habit of only consuming information that already agrees with what you believe. Here's the thing about your brain and beliefs. From a neurological perspective, beliefs aren't just ideas stored somewhere in your cortex. They're physical neural pathways. When you form a belief, a network of neurons fires together repeatedly until the connection becomes strong and efficient. This is Hebb's rule, the foundational principle of neural learning. Neurons that fire together wire together. The more a belief is activated, the stronger and faster the pathway becomes. And the stronger the pathway becomes, the harder it is to reroute. This creates a problem. When you encounter information that confirms your existing belief, the established neural pathway fires smoothly and efficiently. It feels good. It feels right. Neuroimaging studies have shown that belief-confirming information triggers activity in the brain's reward centers, the same areas that light up for food, sex, and social validation. You are literally getting a dopamine hit every time you encounter something that agrees with you. Your brain is rewarding you for not thinking. But when you encounter information that challenges your belief, something very different happens. The anterior insula and the amygdala activate. These are threat detection centers. Your brain processes contradictory evidence the same way it processes a physical threat. It triggers a stress response. Your heart rate increases slightly, cortisol rises, and your brain immediately begins generating counter-arguments, not because you've rationally evaluated the new information, but because the threat response demands neutralization of the perceived danger. Psychologists call this motivated reasoning, and it happens so fast and so automatically that most people have no idea it's occurring. By the time you're consciously aware of the challenging information, your brain has already built a fortress of reasons to reject it. A study from Yale University demonstrated this beautifully. They gave participants math problems embedded in politically neutral scenarios. People solved them based on the actual numbers. But when the exact same math problems were embedded in politically charged scenarios, like gun control statistics, participants who were otherwise skilled at math suddenly couldn't solve problems whose correct answers contradicted their political beliefs. Their math ability didn't change. Their motivation did. They literally became stupider when intelligence threatened their identity. The smarter they were, the more creative their motivated reasoning became. Higher intelligence didn't protect against the bias. It made the bias more sophisticated. And social media has turned this into an industrial-scale cognitive catastrophe. Algorithms are specifically designed to show you content that generates engagement, and nothing generates engagement like content that either strongly confirms or strongly threatens your existing beliefs. So you end up in an information ecosystem that is either constantly reinforcing what you already think or constantly putting you on defensive alert. Neither state is conducive to learning. Neither state allows for the kind of open, flexible, curious thinking that actual intelligence requires. Experienced researchers in political psychology have a term for what happens to people who spend years in ideologically homogeneous information environments. They call it attitude polarization. Beliefs don't just stay the same. They become more extreme, more rigid, more resistant to evidence. The neural pathways don't just strengthen, they calcify. And once a belief has calcified, the energy required to change it becomes enormous. Not because the evidence isn't available, but because the brain has become physically structured to reject it. It's like trying to reroute a river by asking it politely. The water has been carving that channel for years. It's not going to change direction because you showed it a map of a better route. One psychology professor at a major university told his students something that stuck with many of them for years. He said the moment you feel certainty about a complex topic, that's the exact moment you should be most suspicious of yourself. Because certainty feels like knowledge. But neurologically, it's usually just familiarity. You've encountered the same argument so many times that the neural pathway fires effortlessly, and your brain interprets that effortless processing as truth. Psychologists call it the fluency heuristic. The easier something is to process, the more true it feels, which means the more you expose yourself to the same viewpoint, the more true it feels, regardless of whether it actually is true. You're not becoming more informed, you're becoming more fluent in one particular story. And fluency is a terrible proxy for accuracy. And this is where all 6 of these habits converge into something truly terrifying. They don't just coexist, they compound. Sleep deprivation weakens your prefrontal cortex, which makes you crave junk food, which inflames your brain, which makes you more impulsive, which drives you to social media, which fragments your attention, which makes you avoid hard thoughts, which makes you retreat to information that feels comfortable, which confirms your existing beliefs, which makes you more rigid, which makes you less likely to change any of the behaviors causing the problem in the first place. It's not a list of 6 problems. It's a single downward spiral with 6 entry points, and most people are spinning on all 6 simultaneously. The real secret to maintaining and actually increasing your intelligence isn't some exotic nootropic or brain training app or productivity system. It's brutally simple. Sleep 8 hours. Eat real food. Put your phone down. Do one thing at a time. Sit with hard thoughts instead of running from them, and actively seek out information that makes you uncomfortable. That's it. 6 things. None of them require money. None of them require special equipment. None of them are complicated. But all of them require you to fight against the path of least resistance that your brain is constantly pulling you toward. And here's the final thing nobody tells you. The fact that these 6 habits are hard to break isn't a sign of personal weakness. It's a sign that you're a normal human being living in an environment that was designed, sometimes literally engineered, to exploit every one of these vulnerabilities. The food industry spends billions making junk food irresistible. Social media companies employ thousands of engineers whose sole job is to make their platforms as addictive as possible. The entire modern economy is built on the assumption that you'll be busy, distracted, sleep-deprived, and emotionally reactive. That's not paranoia, that's the business model. So when you catch yourself doom-scrolling at midnight with a bag of chips, unable to focus on the book you opened 20 minutes ago, avoiding the difficult conversation you know you need to have, and feeling absolutely certain that the article your friend shared must be wrong because it contradicts what you've always believed, just know that every single one of those impulses is your brain doing exactly what it was designed to do in an environment that was designed to exploit exactly that. The question is whether you're going to let it. Because every day you do, you're a little bit less than you were yesterday. And every day you don't, you're building something that no algorithm, no corporation, and no amount of convenience can take away from you. Your mind, the real one, the one that works, the one